Hi guys, we are going to be looking at the doubly linked list. What is the code and then what is the concept behind the doubly linked list? As we discussed in single linked list, there will be a data and then there will be a next pointer. Other than this, there is a previous pointer which is present in doubly linked list. So this is the doubly linked list representation. So A, B, C, D, and it contains data and then it contains previous pointer and then it contains next. For this particular doubly linked list, we can do so many some of the operations. Those operations contains adding a node at the front of the doubly linked list. We can add the doubly linked list node at the front, and then we can traverse the doubly linked list by printing each element A, B, C, D, and then we can insert the node. It can be at the starting and it can be at the end and it can be at some given position which is like 1 2 3 4. At any of these position we can insert. And one more thing is we can delete any node at three particular cases, like three different cases. At the beginning we can delete the node, and at the last we can delete the node, and at some given position we can delete the node. So these are the different kinds of operations we can do. So let's look at one of the case, like how we need to do the operations when we are dealing with doubly linked list. Suppose let's say I want to insert one node at the front of the doubly linked list. So this is the doubly linked list. As this is the head, there can be two different scenarios. This doubly linked list is empty. Then we can say this is the particular node, this is the new node. So we can assign head to new node. That's it. We don't need to do anything. And then suppose let's say head is present. Then we are going to say this particular new node next equal to head. And then head previous becomes new node. And then afterwards we need to reassign head to here. Head equal to new node. Yeah. We are going to assign head equal to new node. So we need to take care of two particular conditions, that is next pointer and then previous pointer. Suppose let's say you want to add one node here in between B and C. So what are the pointers we need to change? We need to change both of these, and then we need to change this previous as well and then this next as well. This next comes here to C, and then C's previous comes here, and then B's next comes here, and then new node previous comes here. So these are the operations we are doing when we want to insert one particular node at this position. We are going to break two pointers and then we are going to reassign them back to new nodes, like C previous becomes new node, and then B's next becomes new node, and then new nodes previous becomes B, and then new node next becomes C. So these are the different pointers we are going to assign. Yeah, let's go go back to the code. So we'll have a node which contains key, and then it contains previous and then next pointers. This is the structure of particular node. Suppose let's say we are going to assign these particular pointers. The head node will represent first node present in the doubly linked list, and then tail node represent the tail, which is end node present in the doubly linked list, and then first will also represent the last node of the doubly linked list, and then temp is a temporary pointer we are going to take. So let's come to traversal of the doubly linked list. Doubly linked list we can traverse by visiting each node, and then we are going to print the key, and then we are going to move to the next node. that we are doing, taking the pointer and then we are moving. Suppose let's say we want to add a node with the value of k. So that's why we are taking new node which is ptr. So we are going to assign the memory and then we are going to assign the value and then we are going to assign the previous and then next pointers to null. Let's say we want to add node. What are the different possibilities? The head can be null. That means the doubly linked list doesn't exist. So this is the new node we are going to add into the doubly linked list. So we are going to assign everything like first, head and then tail to this new node which is created. So head is assigned to ptr, first is assigned to head, tail is assigned to head. What about the next possibility? We are going to insert at the end of the linked list. So first is going to be tail itself. So don't get confused between first and tail. So uh, first will be tail itself. So let's see the operations what we are doing here. So let's take three nodes. This is one node and then this is one node and then this is one node. And then we are going to say this is a pointer and then this is the first and then this is a head. So now first next equal to temp. So we are going to assign first next equal to temp, which is here. We have assigned temp equal to pointer, right? So we are going to assign first equal to this one. And then we are going to assign temp previous equal to first, which is we are going to point here to here. Like the previous pointer should be here, right? So we are just doing the same thing, whatever being done in the code. So we are just taking the pointers and mapping them to next node and then previous node. And then we are going to say, as we added one more node here, the tail is going to be last node, which is new node, which is temp equal to first equal to temp and then tail equal to temp. Why? Because this is the last node. So that's all for this, like adding the node at the end. And then I will store the number of nodes which is present in doubly linked list. So as we have added one more node, so we are going to increment I equal to I plus plus. So traverse we had already seen. So now you want to insert the node at the beginning. Let's say you want to insert the pointer at the beginning. So we are going to assign this like all the things like key and then next and pointer. And then let's say it is empty. If it is empty, then we are going to assign all the pointers to which the new node the newly created pointer, which is ptr. So first is assigned to ptr and then first is assigned to it and then tail is assigned to it. So those are things are done. And then let's say you want to else insert at the beginning and change the head to current node. Yeah. Now it is not empty. That means we 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 need to add. Let's say this is the head. This is the head, and then this is pointer. So what are the pointers we need to change? Head previous becomes ptr, and then head next becomes like temp ptr next becomes head, and then head should move to here, right? So let's erase this and then see again. See, if we see here, temp equal to pointer. So we are taking this temp pointer and then temp in the sense now this is the current like newly created node next pointing to towards the head, and then head previous is pointing to the new node which is created newly, that is temp. And then we need to move the head pointer to the newly added node at the beginning. So we are doing the same, and then we are going to increment as we are inserting at the beginning. Yeah. And then let's say we want to insert the node at the end. So what should we do? So let's say let's take the pointer. The pointer is taken, and then we had allocated key and then next and then previous. Now let's say the doubly linked list is empty. Now the newly created node itself becomes head, node itself becomes first, node itself becomes tail. So we are going to assign everything here. And then one more thing is insert at the insert at end. So okay, head equal to null and then first equal to pointer. Yeah, first equal to pointer and then first equal to head and then tail equal to head. First becomes pointer if head is null. So let's take this, let's remove this and then take everything pointer like head to pointer and then first to pointer and then tail to pointer. Why? Because everything is empty. So we can take that. And then when we want to insert at the end, so let's say this is the tail and we want to insert at this particular end, then we are going to map next to ear, tail next to ear, and then pointer previous to tail, and then we are going to move tail to here. I think that's what we are doing. Yeah, temp is taken here, pointer, and then temp previous becomes tail, and then tail next becomes temp, and then we are moving tail to temp. Yeah, right. Whenever you are dealing with doubly linked list or any linked list, just take the diagram and then follow the pointers and then see if you lose any pointers and then draw some pictures so that you can understand better, so that you can solve better. That's what we are doing right now. And then as we are inserting, we are just incrementing I plus plus. So let's take the function to insert a node at the position P. Let's say we want to insert a node at some particular position. So there can be invalid inputs. Let's say position is 0, then we cannot insert. We are taking as one indexed positions. So if position is 0, then we cannot insert. And if position is I plus 1, that means more than the length, then we can say we need to insert at the end of the doubly linked list. So that is valid only. But if it is greater than I plus 1, then it is not a valid option. It is not a valid option. That's what we are mentioning. Please enter a valid option. And then if the let's say if it is like, there can be two scenarios. There can be three scenarios. One scenario will be when we want to insert at the starting itself, position equal to 1. Then it becomes insert at the beginning itself. As we had implemented previously the function, we are going to call the same function. And if it is position equal to I plus 1, then we are going to say insertion at the end. We are going to call the function which is already we have seen. So that's what we are doing. And then it can be like different position. Now we need to find the position and then map and then change the pointers. So let's say this is the source node and then we want to find some particular position. Let's say you have to find, let's say take 3 nodes. Let's say this node. Now you have to insert at this particular position which is 2. Uh, uh, let's say position equal to 3. That means this is 1, this is 2, and then this becomes 3. Why? Because this needs to be inserted and then this should become 4 and then this should become 5. Yeah. And then we are going to decrement till we reach that particular position which is this position. So we are going to move here and then we are going to decrement. If it is 3, then it becomes, here it will be 3 itself. And then at this particular position it becomes 2, and at this particular position it becomes 1, and then at this particular position it becomes 0. Yeah. So, and then we are going to say source equal to source next, source equal to source next, and then we are going to take the pointers like newly created node, with this particular position. Yeah, we are going to insert at that particular position, right? So we are going to take the new pointer, which is pointer next, and then we are assigning everything here, and then we are going to say ba equal to source. So this particular source will be stored, and then da will be source previous, and then pointer next becomes ba, so let's take this once again. Let's say this is 1, and then this is 2, and then this is 3, and then now I want to insert at second position. So this will be here, let's say 2, and then 2 it will be executed, and then it becomes 1 next time. uh, this will be 2 here, this becomes 1, and then at this position when it becomes 0, then it stops, so it will stay here, and now we want to insert at this position. Yeah. So this will be like source will be ba, this will be ba, and then this will be da, which is previous one. So this is the previous one, and then this is the next one. So what are the pointers we are going to change? We are going to change pointer previous, and then we are going to change da next, and then we are going to change ba previous, and then we are going to change pointer next, right? I think let's see. Pointer next is pointed to ba, pointer next is pointed to ba, right? And then pointer previous is pointed to da, pointer previous is pointed to da, right? And then da next points towards ptr. Yes, da next points towards ptr, and then ba previous points towards ptr. And then as we are saying, we are inserting one particular node, we are going to increment I plus plus, which is here. Yeah. Yeah, it is we need to think of a logic, like we need to draw the diagram and then see what is actually happening. So what are the pointers we are going to change, what till what position we are going to see, and then what is the previous pointer, and then what is the current pointer. And then let's say we want to delete at the beginning. If you want to delete that at the beginning, we can just move head equal to head next, and then if we take temp equal to head and then move head equal to head next, and then we can release the memory by deleting the temp. We can do that as well. So delete at the end. If you want to delete at the end, then that means we need to traverse the tail, whatever tail, let's say this is the tail, and then now we need to traverse tail to tail previous, and then we can uh, we can set tail next to null, so it becomes null, and then this memory this will be taken out. And as we are saying we are deleting, we are going to decrement the number of nodes. Let's say we want to delete at some particular position. If it is out of bounds, then we are going to say it is not a valid, please enter the valid. If it is at the starting itself, then we can delete at the beginning, if it is at the end, then we can say delete at the end. Otherwise, yeah, otherwise we need to traverse till that position and then find that particular node and then delete it. Let's see. Let's say I take two nodes. Let's say I'll take three nodes so that we don't miss any cases. Let's take this is a node I want to delete. Okay, which is at the particular position 2. So now it comes here, and then at this particular time it is 1, and at this particular time it is 0, the position will be, and then at this it becomes 0. So the source will be here itself. The source will be here. So what are the different pointers we need to change? We need to change whatever this particular previous, this, let's say this is previous. So we are taking, yeah, same thing, previous, and then this is after. So previous we can get via a SRC previous. So previous is SRC previous, and after is SRC next. Yeah, we got after, and then we got previous. Now what are the changes we need to make? So SRC, this pointer next, this previous next should become after, and then after previous should become previous. Yeah, previous next should become after. Yes, and then after previous should become previous. Yeah, this is done here, and then we are going to decrement the number of nodes. Yeah, that's what we have done. We are going through all the cases and then find the position. Whenever the position becomes 0, then we'll have that particular node which we want to remove. We'll take the previous and then afterwards of the particular source node, and then we are going to map accordingly, and then we are going to decrement the number of nodes which is present in the doubly linked list. Yeah, these are the different number of different operations we can do. So if you want to discuss the time complexity of each operations, we can do that. So if you want to add one node at the particular first node, then it is a big of one time complexity, right? Why? Because we just need to traverse, take head node, and then we need to match in such a way that head becomes here, and then it will point to first node. And then let's say we want to traverse, we need to traverse each and every node, so it becomes big of n. And then if you want to insert the node at the beginning itself, then it is a big of 1 itself. Why? Because we want to insert at the starting. We don't need to traverse all the nodes which is present. So if you want to insert the node at the end, so if we have a tail pointer, we can do that by using the tail pointer in big of one time complexity. Suppose let's say we don't take tail pointer, then we need to traverse till the end and then find the tail node, and then we need to map. So if the tail is taken, then it is big of 1. If tail is not taken, then it is big of n. So if you want to insert a node at a given position, if you want to insert a node at a given position, then we can say it is big of n. Let's say we have head and we have tail. If it is at the head, it will be big of n. It will be at the, if it is at the end, then it is also big of 1. Why? Because we have tail, we can match using the tail. So if it is at the middle, then one of them should traverse till the middle. So it becomes time complexity will be n by 2. So it is big of n. So if you want to delete a node at the beginning itself, then we can delete that by traversing head to head next. So it will be big of 1 itself, and then deletion of node at the end. So we have tail, so we can do that by easily traversing tail, and then delete node at the particular position. Then as I said, for insertion as well, we need to delete at some particular position. If it is at the starting, it is 1. If it is at the end, it is 1. If it is at this middle position, it is going to be big O of n. So we are going to say worst time complexity, it is big O of n. Yeah, these are the different time complexities when we deal with the doubly linked list. And the pointers is going to be previous and then next, and then particular key whatever present, and then we can do addition of new node and insertion of new node, and then deletion of new node. Yeah, thanks for watching the video. Have a nice day.